And it is that time. We are about to get started here on the filming for the 2023 AMC 10A Problem 1. It was also the 12A Problem 1. If you'd like my predictions about Amy Floor and stuff like that, I will do that in a separate video. For now, I just want to get started. I'll talk about how easy or difficult it was in that video as well. Let's get to, you can look for it on my channel. It'll be separate from the other content. Cities A and B are 45 miles apart. Alicia lives in A and Beth lives in B. So you've got some segment, you've got A, you've got B, you've got 45. A with A, B with B. Makes sense. Alicia bikes towards B at 18 miles per hour. So 18 miles per hour. And Beth leaves at the same time biking towards A at 12 miles per hour. So she's going 3 miles for every 2 miles she's going, right? Because every unit of time, 1.5 times more distance than her. So that would mean that they're going to cut the distance in a 3x to 2x ratio. So how many miles from city A will they be when they meet? So the distances each will travel will be this, and you're just going to sum those up and set it equal to 45, and x is 9 and 3x is 27, and that's what A went. So the answer is E. Let's go ahead and get to problem 2. And continuing on with the 2023 AMC 10A problem 2, also the 12A problem 2. The first 3 questions on both tests are actually exactly the same. The weight of 1/3 of a large pizza. So together with the weight, okay, 3.5 cups. So you're gonna have to start writing some equations. Get started quickly. The first 5 questions are usually about speed as much as possible. So you're gonna put 1/3 of P, P is the pizza, together with 3.5. Let's make it 7 halves. Nobody likes mixed numbers. Maybe they do sometimes, but not right now. Equals is the same as the weight of, so we're doing weight, not cost. Keep track of those details as well. We're going to have 3/4 of the pizza plus 1/2 of a cup of orange slices. A cup of orange slices weighs 1/4 of a pound. Pause here before you plug in 1/4 and make sure it's what you want. What was the C representing? It's representing 1 cup. So if we have 3.5, you have 7/2 times the weight of 1 cup. That's exactly what we do, is plug it in. Plug it in your mind is better. You're going to get 7/8, and here you're going to get 1/8. That is bigger than that. What do we want to do? Probably solve for the pizza, right? What is the weight in pounds of a large pizza? So you're going to move this over here and this over here. 1/8 off of 7/8 is 6/8. So you're going to get 3/4 equals. This is going to be turned into 12ths. 4/12 of P and 9/12 of P. 4/12 off of 9/12 is 5/12 of P. Reciprocal multiply 12 over 5. 4 goes into 12 3 times. That's canceled. 3 times 3 is 9 over 5 equals P. 9 over 5 is 1 4/5. Let's get on to problem 3. Continuing right along with problem number 3 on both tests. How many positive perfect squares? Well, yeah, okay, perfect squares less than 2023. So immediately, perfect squares 2023, you should know the 5s rule, and you probably should know, I'll just go over the 5s trick for squaring things. If you're squaring a number that ends in 5, like any of these, all you're gonna do is grab the non-5 digit, 1, and multiply it by the number that would come after 1 in a number line, 2. 25 gets added to the end. Same thing, 2 times the number after 2 in a number line, which is 2 times 3. So that's 6. Attach 25. 3 times 4, 12. Attach 25. 45 squared. Done it so many times, I just know instantly it's 2025. 4 times 5. So this is background for people who are experienced. They know a lot of these tricks. They've seen 45 squared. If you square 45, you get this. Immediately, you're looking for all perfect squares that are basically less than 45. They need to also be divisible by 5. To be divisible by 5, the base of the square is going to have to also be divisible by 5 because it's prime. That means you're doing 5 squared, 10 squared, all the way to where? We can't get to 45 squared, it's too big. So you're going to 40 squared. That's 8 times 5 and 1 times 5 starting from the beginning. You get A, 8. Let's get to problem number 4. And the first question that was different on the 2023 10A, problem number 4, not on the 12. A quadrilateral has all integer side lengths. Nice. A perimeter of 26 and one side of length 4. Let's immediately quantify this information so you can think about it. I need the sum of these to be 26, and you can call that one 4. What else does it say? What is the greatest possible length? Call that one the largest. We want it to be the greatest. If you took the small notebook class, you would know the triangle inequality also applies to all polygons. The sum of all the smallest sides must be larger than the last side. Direct application of that. Question, could this be 13 and these be 13? No, but that would give us 26, but it's impossible because if this is only 13, these will not sum to more than that. Why is that? Why does it work for quadrilaterals? If you imagine that you have A, B, and C, if A plus B plus C was equal to the fourth side, these legs, if you think of them as sticks, could not bend up. And if they were to bend up, immediately the length would become less than the straight line distance. Okay, so then because of that, D must be less than the straight line distance. So if I bend this one up slightly and I go here, then this being D, there's no way it's the same distance as the straight line. It won't be able to maintain that same value. That distance there will not be as far. Okay, so because of that, we know that then D must get smaller for that reason, and D cannot be 13. Do we need to know that it's 4? We don't. It must be that this has to be down a little bit 12, so that can be 14. Does it say the lengths are different? Do check that kind of stuff. What if there was some condition where this didn't work because the lengths had to be unique or distinct lengths of each side? It doesn't say anything like that, so we're totally fine in concluding that the greatest possible length of one side is 12. Let's get to problem 5. And the final problem of this rapid fire set, the 2023 10A, problem 5. When I finished this problem, I was at 4 minutes and 32 seconds. So that gives you an idea, and I didn't even go as fast as I could. I slowed it down to make sure I'm not making mistakes. How many digits are in the base 10 representation? This problem is honestly fairly easy. All you're going to do is prime factor. So base 10, normal. So you're going to prime factor because you're looking for a bunch of zeros, because zeros are great because then they're just easy to count on the end. So they've had questions like this before. 2 to the 3rd to the 5th power is going to be 2 to the 15th. So 8 is 2 to the 3rd. When you see numbers, stop seeing the number 8. See it as all the things that it can be. 4 times 2, 3 squared minus 1, 2 to the 3rd, right? So 15, 3 to the 5th, 5 to the 5th, instantly. Okay, so 2 to the 15th times 5 to the 10th times 3 to the 5th times 5 to the 5th. That and that gives us 5 to the 15th with 2 to the 15th is 10 to the 15th. 3 to the 5th is 243. 243. Throw on 15 zeros. You might be uncomfortable with that. The answer is going to be 18. You might be uncomfortable solidly concluding that there's going to be 15 zeros or something. You can just test it like this. If you do 3 times 10 to the 1st, you get 3 with 1 0. If you do 3 times 10 squared, you get 300, which has the same number of zeros as the power of 10. So if you might have not done that in a while, give yourself little things like this to convince yourself that you're correct with that assumption. Most of you probably just made the assumption and moved on, but do be careful in case there had been a 19 here or something like that. Just make sure that you're checking these little conclusions if you're not used to making them. On to the next set of 5.